Hi, good morning, everybody. Just waiting for a few more people to join us in the room. Good morning, everybody. Those of us joining us online, and to those of you who join us in the room, thank you for braving the heat and no doubt the trains that will let you down later on. So we do appreciate your efforts. Welcome to ABL's Maritime Market Briefing here at the Old Lloyd's Library in London. Today we're going to be talking about specialty vessels, self-elevating units, and the risks they present to underwriters. This briefing is accredited by the Insurance Institute, Chartered Insurance Institute, and delegates who are participating can claim one CPD hour for their participation. And to enable us to do that, we need you to register on outside if you haven't already, or you can also contact us online as well. I know some of you here today in the room work in the building, so you may not have registered with us upstairs. So if you could do that, that would help us greatly. And just a quick reminder today as well, we'll be ending the webinar portion of the briefing after the technical presentation, and the marine casualty case reports will be presented just in person in the room today. Of course, we are happy to discuss any issues or any topics with you if you would like to contact us post-briefing, either by email or just give any of us a call. I'm very pleased to welcome our presenters today. Emil is a marine warranty surveyor and marine consultant from our ABL Poland office, and he'll be presenting today on the technical part of the presentation. And we welcome back Oliver Tattershaw, who is a naval architect with our development programme here in London, who'll be doing the case reports afterwards. Chatham House rules apply, the usual rules apply as well, and any opinions or comments expressed here today are those of the presenters and not necessarily those of ABL Group or any of its associated companies. So this is an important part for us, the feedback. We need this feedback to be kept relevant, and we need as much feedback as we can. This really helps us with our CPD accreditation, which we have to renew on a regular basis, and they keep a close eye on us. So if you could take a minute to scan this QR code, and it'll also be in the follow-up emails, so we can hear what you want from us, and maybe we can find some topics from you, what you want us to speak about as well. Many of us here at ABL are ex-seafarers, so this is something that's quite close to our heart. And although a crucial occupation, it can come with risks. And obviously our thoughts are still with the departed and the families and friends of what's going on, both in the Red Sea and in the Straits of Hormuz. We still think there's something around 20,000 seafarers impacted in the region, so it's a significant number. We take our commitment to supporting seafaring well-being very seriously, and we support Stella Maris along with some other seafaring charities in their important work in this area. We are also a signatory to the Neptune Declaration on crew change, which might have started way back in COVID, but it's still very valuable work they do today in ensuring seafarers' rights are protected and repatriation of seafarers goes along as it needs to. So after that, I will hand you over to Emil, who's going to take over for the technical presentation. Thank you.
Thank you. Thank you, Mark. Good morning, all. My name is Emil Vedarte. Doing my first year with the ABL, after 23 years at sea, I decided that it's time to change something in my life. Wanted to spend more time at home. Unfortunately, it doesn't work this way, as I learned. But here I am in front of you today, having spent a number of years on the self-elevating units. I think they are presenting quite a number of risks that I've been challenged and faced with. And I think you, as the underwriters and the brokers, have a very, very powerful tools in your hands that can enhance the safety of the crews that are working on these vessels. So I hope that my presentation today is going to help the whole industry. So the self-elevating units, they were developed in the 1950s. And the reason for that was that the drillers, they wanted to move from the shore towards the water to find more oil, extract it, so that we can run our economies on. So while moving away from the shore, in the beginning, they were using basically wooden walkways on the or piers that were going out to sea, but they had to move farther and farther away from the shore. So they thought that maybe a jackup or a self-elevating unit will be a way to do it. And the first ever built jackup was constructed in the 1950, and the name was the Long Rig Number 1, and it was a barge that was kitted with 6 legs. In 1955, the first triangular jackup was with lattice legs was constructed, and this is something that we are seeing up till now, because this is the main design of the drilling rigs that we are seeing operating on the seas. The interesting thing about this jackup constructed in 1955 was that it was constructed by Zapata Offshore, and it was a company that was owned by the George H.W. Bush, 41st President of the United States. 10 years later, in 1965, the first jackup Hustler with movable cantilever was constructed. So prior to that, it was impossible to move the jackup once it was supported by the legs on the seabed. But with the extendable, movable cantilever, it was possible to change the position where you were to drill, because your drilling package would slide out and then slide to the sides. This would allow only one jacking operation to happen, and you could drill a few wells from the same location. And then 4 years later, in 1969, the Offshore Mercury was the first ever jackup constructed with self-propulsion, because before that, they had to rely on the tugs to change the position, while the first one, Offshore Mercury, had its own thrusters, its own power, so it could move independently of the other units. And another milestone was in 2004 in China, the first ever self-elevating unit that was used for offshore wind turbine installation was constructed, and it was Mayflower resolution. So it took us a bit more than 40 years, or almost 50 years, to start building the units that were purpose-built for the offshore renewable industry. But what self-elevating units are? So self-elevating units is a floating unit which is designed to operate as a seabed stabilized unit in elevated mode. So basically, we have a barge or a vessel that when needs to be in position can lower its legs and go out of the water. Why do we do it? The only reason why we do it is that we require a stable platform that will allow us to carry out the crane operations, the construction operations safely. When we are installing the blades in the nacelle of a wind turbine, we are talking about millimeters accuracy and people inside the nacelle that have to guide it on the bolts. So it's the safety of personnel that is constructing that requires us to have that stable platform. The same goes with the drilling. So the jackups, we call them the jackups. Let's say the official name is self-elevating units, but the unofficial name is jackups. Across the point in the US, they call them the lift boats, yeah? But it's still the same thing, yeah? They are used offshore for many purposes. The main one, as you saw from the 50s, it was for the offshore drilling. But not only, because they can be used for the production and export of the oil and gas. They can be used as platforms for accommodation and workshop services. Because if you have a platform and you need to renovate it, refurb it, then you need a lot of workforce that you can't put it on the platform because it has limited capacity. So you need an accommodation platform next to it that is going to accommodate all this personnel. So it can be used for the accommodation and workshop purposes. Recently, we are seeing the jackups being used for decommissioning, especially over here in the North Sea. Our assets are getting older and older, and they have to be decommissioned, yeah? Because the oil, gas, they are gone, so we have to get rid of it somehow safely, and by the use of stable platforms as jackups. Then, offshore construction. As I told you, especially nowadays, the offshore renewable sector, installation of the wind farms, foundation, wind turbines, this requires offshore construction jackups. But what I've seen recently, especially from the last year, unfortunately, Chinese Army has constructed a fleet of the jackups that are intended to be used for military landing. Yeah, there is a fleet of jackups that basically on the bow, instead of a crane, as you see on this beautiful jackup that I had the privilege of being the commander of, they have a collapsible bridge that you can land on the shore and transfer your tanks, your armored vehicles to the land. Yeah. So as you can see, the variety of applications is great. As I already told you, the jackup can be either ship-shaped, so it can resemble a ship as on the previous slide. Yeah. So it has a hull like a legitimate ship, or it can be a pontoon barge. And this hull allows them to float when they are on the water. But we already said that the main mode of operation for them is when they are elevated. So in order to elevate, they need a set of legs that they can lower on the seabed to allow them to get out of the water. But on top of that, there is a mission-specific equipment that is also very important, that is installed on the deck. In case of the drilling jackups, it will be the drilling package. So your drilling derrick, mud pumps, mud tanks, etc., blowout preventers. On the construction jackups, it's going to be a huge crane or two cranes that have a massive lifting capacity. We are talking about 1,500, 3,000 tons. So massive equipment. Or as in case of this jackup, this is a service jackup next to a platform in Persian Gulf. And over there you can see that it has accommodation facilities in a gangway that allows the personnel to come on this unmanned platform and service it. As for the legs, the first differentiation between the jackups can be by the legs. For example, over here you can see a drilling jackup, triangular hull with 3 legs. Behind it, you can see a service jackup with 4 legs. Yeah. So the legs are either tubular or they have lattice structure. Yeah. In the back of the picture, you can see a jackup with the tubular legs, and in the front, you can see a jackup with the legs that have the lattice structure. Each one of them, type of these legs, have their own set of benefits, but unfortunately, they also have flaws. The tubular legs can be either cylindrical or square in the cross section. They are very stiff and they can bear more load. So you can have a heavier unit that can elevate out of the water. But the problem with them is that they are very heavy. And since they are very heavy, they can't be long enough. So these jackups with the tubular legs, they are operating usually in the shallower waters than the ones that have lattice legs. Because lattice legs, they are lighter, so we can construct them longer and we can operate in the greater depths, up to 100 meters. So that's a substantial depth already. But for the offshore industry, we class it as a very shallow water. Yeah. And the lattice legs as well. They can be triangular, but they can be square in the profile. The problem with them is that they are not stiff as the tubular ones. So the loads that they can bear are lower than the tubular ones. So when the owner wants to design his jackup, he needs to decide what depth is he going to use it in, what purpose, and how heavy it's going to be. So this is the decision that has to be made on the design process. Yeah. In the bottom of the leg, you have a bottom support, something that allows you to increase the contact area between the leg and the seabed. Because the tubular leg is hollow inside. So if you were to drive it into the seabed, it would penetrate it a lot. The same goes with the lattice one. If you drive it into the seabed, it would penetrate it a lot. So you want to increase the contact area so that you don't penetrate too much. Because if you penetrate a lot, then it means that you are going to lose this leg length that allow you to go out of the water. So you decrease your water depth. So what we are using is something that is called either a spatkan think of it as a foot on your leg. So this patcan, it has a tip in the bottom to stabilize it, and then it allows the leg not to penetrate as much if you just had the lattice structure, or if we are not using the patkans, there can be mats installed on the seabed, common mats, so that you put your legs on the mats that allow the legs not to penetrate too much. So having talked about the, let's say, the construction divisions technicalities of the jackups, let's dive into the mode of operations and the risks they carry with it. So as you can see on these pictures, the same vessel in two modes of operation, one of them, the vessel being afloat, the other one, the vessel already in location being elevated. But I like to differentiate also the third mode of operation, which is the most dangerous, and it's the transient state. So it's the state between being afloat and between being elevated. The moment when you go out of the water or the moment when you go into the water, as this is the most dangerous one. When the jackup is afloat, it's basically behaving like a ship or a barge on the sea. The problem is that the seaworthiness of this unit is low. It's much lower compared to the normal seagoing vessel. The reason being, they have lower freeboards. So the hull doesn't stick up the water as much as in case of a container ship or a bulk carrier. Another problem is that the hulls are not as deep as with the vessels. So the draft is low, the freeboard, as I said, is low. The bows do not have the bulbs, so the bows are short. So there is a chance that in the seas, as you can see with this jackup on the right-hand side, the bow can go out of the water and it can slam on the water, which is not something that we want because this can cause stresses and failures. The problem with the jackup is that, as you can see, you have very, very high legs that are protruding above the water into the sky. And they are not designed to be, to have high motions. So we want to minimize the acceleration on top of the leg because this can cause the leg to break. Yeah. But the biggest problem for these vessels is the loss of buoyancy. Basically, the vessel sinking. Why? Because I already told you about the low freeboard. Another risk is loss of watertight integrity. These types of vessels, especially drilling jackups, when they are out of the water, they have to accommodate a lot of drilling material that is going to be used in the drilling phase. Muds, bulks, chemicals, drilling pipes, cement, casing. So all that is heavy, and there is a limit how much mass you can put on a jackup. So the tanks in which normally you hold the ballast water when you are at sea have to be drained. Not only you pump out the water, but you have to go into the tank with just certain precautions, open the drain plugs and drain the unpumpable water. So if you have dump valves and drain plugs in the bottom, then it means that you have in each tank an element that can fail. If it fails, then you have water ingress. When you go out, when you go down on the water, yeah? We are talking about brass plugs that are being threaded into. And if the thread is not good, the water pressure is just going to make it pop, as you will see on one of the next slides. Since the vessel is on the water, the certain normal risks that I would say for the rest of the vessels, like collisions, like groundings. But we are talking about units that are operating in very close vicinity to other platform structures. We are talking about meters. Offshore installation jackup approaches the structure to the distance of approximately 8-10 meters. If something happens during the approach, you are going to collide with it. And if you are going to collide with the structure, unmanned structure, it's not a problem for the structure, but it can be a problem for your vessel and for your crew, which can sink. Yeah. Grounding. When jackup is approaching the location, usually not to lose the time, we lower the legs ahead of the time. And they stick up above the seabed a couple of meters. But if the survey data that we have is not reliable, there is a chance that I'm going to destroy something or I'm going to ground. Or like with any other ship, you lose your own power and you can run aground. A lot of jackups do not have their own power. they are not self-propelled, so they have a risk of tow failure. If they are being towed by the towing vessel and the tow fails, sometimes by 1, by 2, by 3 vessels, it depends. But if the tow fails, then you have a dump barge without the propulsion that is just left there to go any direction Neptune wants it to go. Yeah. And then we have the structural damage. I told you about the legs. If the motions of the unit at sea are high because of the environment, be it wind, waves, etc., the legs can fail, the legs can break. So what you do in that situation, usually we lower the legs so that when they are lower, then the accelerations are a bit lower, but there is a limit how low you can lower them. Plus fire, like on every other vessel, or a jackup being towed, and a lot of them are operating in the areas that are prone to, let's say, piracy, being the Horn of Africa, Nigeria, etc. When they are being towed, they are not fast. We are talking about 4 or 5 knots of speed, which is around 10 kilometers. So this opens them up. They are very vulnerable to the pirate attacks. So this is an example of a wind turbine installation vessel that sank in July 2021, so only 5 years ago, in China, in Guangdong province, when it was approaching the foundation of the wind turbine. As you can see over there in the back, behind the sinking vessel, there is a structure. So this is a transition piece on which you install the offshore wind turbine. So when it was approaching, it collided with the structure and unfortunately lost the buoyancy and sunk. As a result, 4 persons were missing out of crew of 65. Next example, this is a capsized lift boat. Over here, you can appreciate how low is the freeboard. We are the depth of the hull. We are talking about a couple of meters, maybe 4, 4.5. So as you can see, the hull or the deck is not too high above the water. And what happened in this case is that they left the port, and after 3 hours they sunk. We are talking about same year, April 2021. One of the contributing factors were the tropical storm force winds and high waves. This has resulted in a sudden storm, which was beyond the operating limit of this unit and caused the unit to lose the buoyancy and sink. So as a result, 5 people were found dead and 8 were missing. Another example, this is from our region, from Europe. In Denmark, on the night between 26 and 27 of January, the tow line broke. So the vessel was being towed by one tug, the tow line broke, and as a result, the jackup barge ran aground next to Hvide in Denmark. Almost a week later, during the salvage operations, due to the further adverse weather, the vessel sunk. And if the vessel sinks, that's a massive problem, especially from the perspective of, because everybody was already rescued, but it's a problem for the environment because there is a lot of oils, fuel that are still left in the hull. Yeah. This is an example of a unit that unfortunately I was the commander on. When we were coming on the water after being elevated, what happens is that you need to take time to make sure that your water integrity is fine, so that none of the plugs have popped. Yeah. So what usually happens when you get to the water level, you send the crew and they sound all the tanks, all the empty spaces, and then you see if there is any water ingress or not. Yeah. We noticed that in one of the compartments there was a water ingress, and this small fountain is a result of a popped drain plug. Yeah. The other video, that's another interesting story. A week later, when we elevated up, when we were doing the preload, so when we were loading the legs to prepare to go out of the water, it turned out that the repairs done in the shipyard were done in not the best manner. So as you can see, the water is over there flowing into the transformer room. And this being electrical equipment that is used for jacking is not, let's say, designed to work in a wet environment. So basically we lost our jacking system and the rig was stopped for a month. in not the best position, only half a meter above the water. So susceptible to further damage due to the slamming of the seas. And this has happened within a week. So no major accident. Everything was being dealt with safely, but unfortunately these things happen. And I would not be standing here in front of you if I have not seen it with my own eyes. There are a number of reasons why did it happen. But I think, as I said in the beginning of presentation, you have the tools as the underwriters, as the brokers, that can prevent it. But let's go to another mode of operation when the jackup is elevated. So we are already at a working elevation when we are a stable platform for the drilling, construction, or accommodation operations. But it doesn't mean that we are safe, because there you are still prone to the risk of collision, because this platform is not self-sustainable. You still need fuel, you still need food, you still need to change your personnel. And to do that, you need to have supply vessels. You need to have helicopters. And collisions of the supply vessels with the platforms are not something uncommon. Just 2 months before I joined one of the platforms, they have collided, supply vessel has collided with the leg. So it does happen. Then there is a risk of fire, especially on the drilling rigs. There is a risk of blowout. So the well being unstable and the fluids or the gas coming to the deck, and you have to somehow control it. Then there is a risk of structural failure. So, for example, your legs will fail under you, and then the whole platform collapses. There is a risk of earthquake, because when the earth quakes, then your stable platform can mean that you are not stable anymore. Or there can be a risk of liquefaction, which is basically, again, your stable seabed not being stable anymore. The biggest one is the risk of punch-through that we will discuss shortly. And there is always the risk of the storm damage, because these rigs are designed to be safe up until a certain limit of weather. So if the weather deteriorates beyond this limit, they can fail again. As an example, over here, we have a drilling jackup that suffered structural failure to one of the legs during drilling operations. And this has happened in 2024, so only 2 years, 1.5 years ago. So it's not something that has happened long time in the past and it's not happening anymore, because these things happen, and even in recent days. So this failure of a leg has caused the whole cantilever that was steered out to collapse. So we are talking about major damage that was caused to the well structure and the platform. And this has happened offshore Trinidad. Another example, as you can see over here on the first 2 pictures, this is actually the same platform. As you can see, a fire that has damaged not only the self-elevating unit, but also the platform that she was working on. Yeah. And in that state, you can't lower the jackup anymore because you lost your electrical equipment that is driving the jacking system. So we are talking about major decommissioning work that is to be happening over there. Another example is a jackup that was alongside the platform that has failed structurally and is now in a state afloat or semi-afloat, but can't go anywhere. So again, the platform had to be shut down. So we are talking about major losses. I told you about the collisions. So here on the picture, you can see something that has happened in September 23. Supply vessel lost position during cargo operations. And since the hook was still connected, the rig crane's hook was still connected to the cargo, when the vessel was losing the position, the crane wire was following and it damaged the flare boom used for the well testing operations. Yeah. In 2021, over here in the North Sea, emergency response and rescue vessel collided with a port deck of the drilling jackup. So a vessel that is responsible for the safety of the personnel on board has caused the problem for the jackup. 2 years ago, again in the North Sea, jackup leg supply vessel made contact with a jackup leg. So it does happen. It does happen everywhere. And the most problematic state, transient state, historically, the highest number of accidents happen when you are in this state. The risks are the damage to the legs due to excessive hull movements just before touching the seabed. So remember that when you are afloat, your legs are just above the seabed the moment before you touch the seabed. And if the seas make the hull go up and down, you can slam your legs to the seabed and destroy them. You can damage the hull when you are preloading due to the high seas, because your hull is just above the water. And if the weather picks up, the seas that will be slamming from underneath your hull can damage the hull. You can punch through, so basically the seabed will give way under you, and if it gives way under only one leg, then you are going to collapse. Or you can have a structural or mechanical failure during the jacking. You can damage the spat cans if you land them on the rocks, or you can damage the pipeline or a cable if you put your leg on the pipeline. Or you can collide with a jacket or with the foundation that you are approaching because you need to work next to it. So this is something that I have seen with my own eyes from a distance. In 2023 is 2013 in Angola. That was a jackup that was preloading. So basically, preload operation is an operation where you artificially increase the load on your leg to make sure that the seabed is compressed so that you can safely go out of the water, and you know that none of the forces that you are going to introduce is going to make the seabed give way. And it's a very dangerous operation, because if it's done without necessary knowledge, without necessary documents, it can finish like that. So this platform, when they were preloading, one of the legs, seabed under one of the legs gave way, they tilted up to a way when the legs started breaking, and as a result, in a matter of hours, they sunk. So not only we have a total loss case, but also the whole project interlinked with it got delayed by a number of years. So we are talking about massive losses just because at some point someone decided that we are going to cut a corner or two. So what is a punch through? Punch through is a rapid penetration, and it is a critical hazard to the jackup. It occurs when the strong soil overlays weaker soils and causes sudden, uncontrolled leg penetration. Potential punch-throughs can be identified very well through geotechnical soil investigation, but this requires the operators to spend extra money, time, and effort to make this job to be carried out safely. Unfortunately, these type of accidents account to over 50%. So that's a huge number. And we still, 70 years later, were not able to eradicate them. And again, saying that, I think that you are the ultimate ones who have the most powerful tools to fight for that. Because with the number of companies being run by the accountants, money is important.
How about this 50%? How many survey? Do you have any idea? Pre-survey? Because to be fair, there are some where the area is surveyed, but still happening.
Unfortunately, I do not have that data. I can tell you that majority of them had the survey data, yeah? But then the question is, what level of survey was carried out? How old was the survey data? Maybe it was carried out 5 years ago, because certain operators, they require the data not to be older than 2 months to make sure that you have the most recent data, yeah? So having said that, you have the tools in your hands because you can force your clients to put additional layers. That, at least that's my opinion, and I hope that the reason why I'm here is help to eradicate that problem. So, as you can see, we've already said that the punch-throughs, they account for more than 50% of the accidents, but then there are different types of punch-throughs, yeah? Because they can happen when you are jacking up, they can happen when you are preloading. The greatest number of punch-throughs happen when you are preloading. So basically, when you are putting the load on your individual legs, the preload operation can be done in numerous ways. And it's usually the marine warranty survey company that can help the client to identify potential risks and find a way how to do it safely. Another question is the company will follow that suit. Yeah. On the graph over here, you can see something that is it's an extract from a document that is called leg penetration analysis. So based on the survey data, specialized companies can create graphs like that, and this allows the crew, the company, to make decision if it is safe to put your jackup over there. Over there, you can see the estimates of the lower and upper bound strength, which basically tells you what is the minimum force that you have to apply on the seabed so that it compresses, and the maximum force before it fails. And on the horizontal line, you can see the load, the actual load that you are going to put on that soil. There are two dashed lines, vertical dashed line. One is the still water footing reaction. This is the reaction when the jackup, without any external loads, is just out of the water. So this is your minimum penetration that you should expect. And then you have the second on the right line, which shows you the preload footing. So the maximum force that we have to preload the legs to make sure that when the vessel goes out of the water, any force that we are going to exercise on any leg will not cause it to punch through. And as you can see in this graph, it is possible that when we will be loading the vessel or each leg from the still water to the preload reaction, that the seabed will give way. So we can have a punch through. But we can have controlled punch throughs. We have safety measures. We can do that when the vessel is half submerged, so that the buoyancy, if the seabed gives way, help us not to tilt too much, not to damage our legs. But again, you require someone to be supervising that so that it is carried out safely. And this someone can be, for example, marine warranty survey company that is responsible for the marine assurance. And again, it is you, the underwriters and the brokers, who can enforce that, because you can, in your rules, say that you require such level of supervision. These are some of the drawings taken from the site-specific assessment documents showing you how does the seabed look like, so that when you are positioning your jackup, you know exactly where old footprints are, so that you don't slide into them and possibly collide with the structure, so that you do not exercise forces that on the legs that will cause the legs to fail. This is the level of data that is required as a minimum to be taken into consideration to have the jackup positioned safely and out of the water safely. And if you do not enforce the clients to have that level of information, unfortunately, we are putting people's life at risk. So this is an interesting trend. The orange bars are cumulated incidents that have happened on the jackups between 79 and 89. So we are talking about a decade. And geotechnical source of accident, being, for example, a punch through, etc., accounted to 23 incidents. Between 96 and 2005, which is the yellow line, we had 38% more accidents like that. So even though 15 years have passed, the number has grown. It's also because we had greater amount of jackups operating, but we should be seeing different trends. Because already 15 years, 20 years have passed, we should have had barriers in place that were preventing that accidents happening. As you can see, this is the most contributing factor. Then another one is towing line failure, blowout fires, but this is, let's say, drilling risk that is managed somewhere else and not our topic today. And the most recent data, so the accidents between 2013 and 2021, as you can see, the initial hazard, so when the units were under the tow, when they were afloat, we had one CTL that was due to the flooding. When the vessel was in close quarters to the installation, so in a transient state, we had 3 CTLs that were due to the punch-through. And we had 5.5 severe damage. How come 5.5? Because one of them is classed half as a punch-through and half as a jacking system failure. Yeah, but we still have high numbers. We should be seeing not more than 1 over here. But only due to the punch-through and jacking system failure, within 8 years, we had 3 total losses and 7 severe damages. As for the drilling failures, we had 2 blowouts. So in total, 4 CTLs and 9 severe damages in only 8 years, recently. And our aim would be to see 0 over there. So how can we mitigate these risks? The most important, in my opinion, is the training, because it's the crews who are executing these operations. If they do not have enough level of knowledge, if they do not appreciate the risks, they are destined for failure. So it's the training that is the most important factor. The next one being marine assurance. And this is something, again, that you might have the influence on when you are writing your business with your clients. The seabed surveys, if you do not have the reliable data, you are prone for accidents like that. Along with the seabed survey, it's the leg penetration analysis, site assessments, and location approvals that are required. One of the biggest contributing factors is the time pressure. If there is the time pressure on the crews, from the operators, from the companies, unfortunately, there is the tendency to cut the corners. Think of a situation where I shown you the video when the plug popped up. There was a time pressure for the client, from the client that I was working for, not to lose 3 hours for this watertight integrity check when we were sounding tank by tank. They said, why do you need to do it? And I stood my ground. I said, I don't care. What's your problem with the time pressure? I'm commanding over here, and I say that we stay here and we use this time because I need it. Had I relied on the client and bent to his time pressure, maybe we would have sunk. So if you remove this time pressure, then again, it can be safer. And the biggest problem that we do not talk about is the stress and the fatigue prevention. Because when you are preloading your jackup in a demanding location, it can take a lot of time. It can take 24 hours. And the numbers of the crews on the jackups are being ridiculously lowered. When you are pulling the legs and you have high penetrations, it can take 3 days to pull your legs. And you have the same people that are sleeping on the bridge next to the console. And it happened to me once that the jacking operator, I had to look at his fingers, which buttons he is pressing, because I could not rely on him anymore. I saw that he was, falling asleep, standing. So if the crews are fatigued, if the crews are stressed, again, we have a potential failure over here. Something that you rely on and we rely on is the Joint Rig Committee Rig Location and Move Code of Praxis, JR 2019-005, which says that the fundamental objective of the marine warranty surveyor is to make reasonable endeavors to ensure that the risks associated with the warranted operations to which a marine warranty surveyor is appointed are reduced to an acceptable level in accordance with the best industry practice. So if the marine warranty surveyor is assigned to the checking job, then it means that he should do everything, regardless of what the client says, to make sure that the job is carried out safely. So this is something, again, that I'm saying you have a huge influence on, because you can force your clients to stick to this code of practice. And the marine warranty survey process during the rig moves starts very, very early, ahead of the rig move. It starts with the detailed review of the rig details, of the location, of the seabed, geotechnical data that is provided from the survey, Then we assess the tags, we assess the move procedure, and if we are satisfied with everything that we are seeing, we are issuing the location approval, which is a document that shows that this can be, or let's say, necessary precautions at this stage have been taken. While we are on site during the rig move, first, we again check the tags, we check the rig, we make sure that it can be done safely, that going onto the water and starting the rig move can be done safely. After that, we review, we witness the preparations, we witness the operation, we can stop it, we make sure that people know what they are doing. And once we are happy with what we are seeing, we can issue the certificate of approval for the individual rig move. And when the operation starts, we are there, we monitor the operation. Again, we try to help, we advise, but most important, we make sure that everything is done as it should be and the corners are not cut. When we are at the operation, we witness the jacking operation, we witness the watertight integrity checks, we witness the towage, we witness the final approach, and again, preloading and jacking. So the involvement of the Marine Warranty Survey Company will be from the early stages to the very, very end of the operation, trying to cover any aspect to make sure that the operation is done safe. It doesn't matter that things can't go wrong, because there can be hidden flaws, there can be something wrong with the survey data, but at least it's another layer that can make sure that the operation is done safely. Thank you very much. I hope that I haven't bored you to death, but I think I had to speak up for the people that are working for the jackups and they need a bit more safety. Thank you very much.